Hi everyone. Today we're going to talk about timers. Now, before we jump into the PLC program, what every timer and when you're dealing with timers you must consider is a timing chart. Timing charts are very useful in terms of determining exactly what we want to see. Right up here I have the timing chart of an Omron industrial timer. And this is an on delay mode, and there are several different inputs here, and these inputs: power, start, reset, then you have your output relay normally closed, output relay normally open, and your power indication, which is on the front of the timer itself. Over this side here we have just a basic operation of the timer. So power comes on, we have a start signal, we have time, and then the output actually turns on. So the timing chart itself is the actual secret behind using timers, and if you can come up with a timing chart for your application, the actual programming becomes much easier. So here we see when power comes on and when the start is on at the same time. Here's what happens when the power goes off, and it shows everything in between. So in the PLC, the power would represent memory-retentive or non-memory retentive. So there's our start signal. If we get multiple start signals, what happened? In this case here, nothing happens, it just keeps timing. We have a reset signal, which actually resets the output and allows for the next time cycle to happen. So as you notice, along the y-axis we have time, and on the x-axis, the y-axis we have state, and on the y we have time. Now if we look at a quick example, what we'll do is we'll have a start, a warning light, and a motor. So basically in the PLC, when the start is hit, the warning light comes on, and then the motor activates. So that's our sequence that we want to program in the PLC. So what we're going to do is call up the Do More Simulator, and then we'll call the program. And as you can see, our start signal, this is the same latching type circuit that we discussed previously. So it will come on. We will then have an internal bit, C0, which then will start a timer. This timer is set for 10 seconds. Once that 10 seconds is done, then it will actually turn off of the warning light. And if the warning light is off, the motor then starts. So that's our whole timing sequence. And you'll notice here this first scan flag. Internal memory bits C0s are memory retentive, so we need to reset them. So if we were to just start this unit, hit start, we'll look at the PLC program. You can see we have timing going on, and we have our warning light on, and after the 10 seconds our output motor comes on. Even though our start signal is still on, and so we'll turn that off. And once the rung becomes off, what we'll do is reset the whole unit. Okay, that's it for today. Thanks for watching.